Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're revisiting a blast from the past. This was an amp that I built about 3 years ago, and a lot of you guys that weren't around back then have probably never seen this amp or know what this is. This is a globe tube amp that I built trying to see how good I could make some 1930 vintage tubes sound using modern hardware supporting it. And really at the time, this was the most expensive build that I had done. Used some Hashimoto HC507U, some EI Core output transformers, used really nice resistors, coupling caps, got a motor run cap for the rectifier tube, put a little vintage meter on it and stuff, and tried to do the aesthetics to match this older tech tubes. And these were some of the first tubes that were actually made. Originally I tried to use a 27 tube for the driver, which is an indirectly heated triode, and the first one that was indirectly heated. And then this is a direct heated pentode, a 47 tube. And this amp's never going to make a lot of power. Probably 1.5, 2 watts is just, the 2's probably pushing it, but just wanted to see how nice it could sound. And it sounded nice, but it had a very low input sensitivity, which means you had to drive it with well over 2 volts RMS to get full volume. So I was ended up running this thing wide open and having to run a preamp in it to get enough drive to have something usable. And it was originally designed as an integrated amp. So I wanted to increase the input sensitivity and talked with my friend Mystery Mark, and we talked over some operating point changes that might be useful, and then go into a 56 tube instead of the 27. Otherwise known as the Super Triode, has a gain of 13 instead of 9, which doesn't sound like a lot, but when you're on the verge of just not quite having enough, that could be the difference. So first thing I tried was some operating point changes on the 27 tube, did some testing, basically got to a point where you could just direct drop in a 56 without changing anything, and then tried that. Did some listening tests, which we'll do at the end of the video, and also got some little constant current source boards that Mark made for me, and I did a little bit of testing on that, but I don't want to do a spoiler, but I want to do a whole other video about using a constant current source and the results from that, and some other adjustments I had to make to the amp, etc. And I'm not even done really tweaking these out. So let's get busy dealing with the load line changes. I'm going to show you how I drew the load lines, what we changed, and then we'll do some Analog Discovery 2 stuff, and then final, at the end, I'll do some subjective review comments about what it sounds like now. So let's get busy. Okay, so first, let's look at the load lines and operating points of this driver tube, and we're going to start out with the original operating point that I got from the RCA datasheet as kind of a standard operating point, and that was using a 22K plate load resistor with a 2.2K cathode resistor. So the way you draw a load line is you first imagine that the tube can go to a direct short, which means that the plate voltage would be 0 if you shorted the plate to the cathode. And then you'd only have the current going across the resistor that would be seen by the plate. That's why it has plate milliamps here. And so if you take the 250 volts, which is the voltage on the other side of the plate load resistor, and if you do the math with 250 volts and 22K, you'll see that you have 11.5 milliamps at the plate or going across that resistor. So you mark that point here on this chart. The other end of the line comes down here to the 250 volts that we see on the other side of the plate load resistor, and you draw this load line. And wherever we set the grid voltage will be somewhere along this line. And the grid bias on a cathode biased setup is with the voltage drop across this 2.2K resistor as the grid's reference to ground, and the grid bias is between the grid and the cathode, becomes the negative voltage. And so we have the bias set at just over 9 volts, which we've marked at this point on the load line, which means we have approximately 4.5 milliamps across the tube, and then we got about 135 volts on the plate at that bias point. And this is what we started with. Now you'll note that the distance between 9 volts and 13.5 volts, as far as like just distance, is a little less than between 4.5 volts and 9 volts. I mean, it looks kind of subtle on this graph, but it's there. And when you're operating at a point where the spacing between the grid curves isn't equal, can create distortion, and also as the distance between these lines gets narrower, you're getting less voltage amplification out of the tube. So we're operating at a point here where we're going to get less swing on the output of the tube than we would if we were over here, but we don't want to be pulling that many milliamps of current through the tube by biasing it at 4.5 volts on this load line. So what we've done is this. We went to a 45K plate load resistor, which cut our current at 0 volts, or if the tube was shorted, in half to right at 5.5 milliamps. And then the other endpoint's the same down here at 250. So we get this load line. And then we went with a lower cathode resistor to lower the bias point to just over 4 volts. And so now we've got about 3.5 to 3.8, somewhere around in there, milliamps of current through the tube, and we're around 90 volts on the plate. And as you can see, we're in this zone where these lines are further apart, which is going to give us more swing on the output of the tube with the same signal, which is what we're trying to accomplish by changing this bias point, is get more drive out of this front end tube. Now, it's not going to be a whole lot sticking with this 27 tube, but we're setting the amp up to be able to use a 56 tube, which will give us a lot more drive. So let's look at what we've got when we switch to a 56 tube. Now, this isn't an identical chart as far as, you know, the layout of all these voltages, but it's really close. As you can see, like here's 200 volts, and that's going to be approximately 200 volts on this chart. And you can see how much further apart these grid lines are, or the grid voltage lines are, which means we're going to get a whole lot more swing on the output of this tube than we did with the 27 tube. And as you'll see in the next video, it makes the input a lot more sensitive, is what we're trying to accomplish. So got the 45K plate load resistor, 1.2K on the cathode. We end up with just a breath over 4 volts on the cathode, and we end up with the same basically 3.5 milliamps and around 90 volts on the plate of the tube with it biased here. And again, you'll see in the next segment when we do the testing, this tube is going to give us a lot more voltage swing, and it has an amplification factor of 13 instead of 9, and that's seen by the wider spacing of these grid voltage to plate voltage curves. The last thing we're going to show you here, we may not get into this real deep in this video, but I do have a constant current source I'm going to be experimenting with. And what the load line on a constant current source looks like is this. It's horizontal, giving its name constant current. The current's going to remain the same no matter what the tube's doing, due to having the MOSFETs controlling the current. And this one is set at 4.5 mils. Probably going to lower it down a little bit, but we'll get into that in the next video. But for now, this just shows you that the load line with this constant current source on the plate is going to be 4.5 mils just across the board. And then the 1.2K cathode resistor is going to set our bias right here. It's going to be a little over 5 volts, like 5.5 volts. And you figure that by doing the Ohm's law math with 4.5 milliamps into the 1.2K, and that tells you what your cathode voltage is going to be. And that's exactly what it was. And then the tube swings along this horizontal line, which gives us more gain than it would if it was going in this direction, because these curves are like at an angle, and if this line's horizontal, you get more swing out of the same input voltage. And again, I think I want to try to move this closer back to this 4.5 volt instead of 5.5 volt, and get around 100 volts on the plate and get it operating in this range here where these lines are nice and fat and even. So that's what the load lines look like. And so let's get busy testing this thing using this information and see what happens. Okay, so we're going to start off with the 27 tube with the new operating point that we changed to try to increase the input sensitivity. And I can tell you from using the amp that it definitely increased the input sensitivity to what I would say is a usable place for it to be. It's still not quite as sensitive as I would like an amp like this to be, but it's way better than it was when I initially built this thing. So let's do a THD versus power pull on this, and let me show you what we've got now. Now, the symptom of lowish input sensitivity is how high that green or bluish line is. Not the blue one, but I guess the green one above it. The green one above it is the input signal, how high it needs to be to make the amp do what it's doing. And normally it's down in this range, you know, it'll be like a line across like right here. And the fact that it's way up here is showing that the amp has low input sensitivity, which means it takes a lot of power to drive it. So if we follow along here, it crosses 1% THD at about 0.9 watts. And then here at 1.25 watts, we have 2% THD, and we have 1.9 volts RMS, which 2 volts RMS is kind of like the max of what you're going to get out of a modern source. And you can see it goes past that right along in here, which is about 1.3 watts. And a lot of modern sources, while they're spec'd at 2 volts RMS, they're really not there. And so even my Phonostage, which has a fairly hot output, still has a hard time driving this. And before I had to just run it wide open, and it wasn't quite enough. But now I can run it about 3/4 volume and, you know, get a reasonable output from my speakers, which aren't particularly efficient. And I'm kind of surprised that this basically 1.5 watt amp is able to drive my speakers. And then Here we'll see at 1.5 watts, we're right at 3% distortion, and we got 2.1 volts RMS to get there. And then finally, up here at 2 watts, we got 7% distortion and 2.5 volts RMS, or 2.6 volts RMS to get there. So let's look at the frequency response curve. And as you can see, from like 100 hertz up, it's pretty flat frequency response curve. I mean, the high point here is around negative 0.4 dBs, and even down here at 40 hertz, we're really at about maybe 3/4 of a dB down. And listening to this amp, it sounds like it has plenty of bass response. I haven't noticed it lacking in that respect. And as you can see here on the upper end, it goes past, it doesn't even start rolling off till 30K. So it's got a very flat frequency response in the range that most music is. If you're worried about this, like at 20 hertz, it is down almost 3 dBs or 2.5 dBs. And so, in the super low bass region, it's not a rock star. But when you listen to the amp especially, it sounds really nice. So let's do some scope readings and see if we can see where it starts clipping. And I'm going to assume it's around in this level here. So let's see what it does with 2 volts in. And you can see it's just starting to get a little wonky here on the top. So let's try 2.2, and I bet we're going to see some pretty good clipping. Not really. Let's try 2.6. Oop, not 26. Yeah, definitely clipping there. But see how soft it's clipping? It's got this really smooth, rounded clip to it. So even when you're like beating on the amp and you're getting transients that go into this range, they're not hard clipping. They're what I'd say is soft clipping. And you're not going to really hear that, especially if it's a real short transient note or a drum hit or something. This isn't going to throw the amp into hysterics or sound really horrible. And 2.6 volts in is, yeah, that's right at 2 watts. I would say generously it's a 1.5 watt amp, and got a little 0.5 watt of headroom here into some soft clipping. So that's kind of what the power level of this thing is. And so if we come in here and we're going to do a THD versus frequency at 1 watt. And this is a really nice curve. It does start out at about 5% at 20 hertz, but by the time you get to 200 hertz, it's down at 1% and just stays there across the whole range. Now, one thing I did note is, like, here's the second order harmonic distortion, and there's the third. And it seems to have a lot of third order harmonic distortion, which honestly is not ideal, but hey, it is what it is. I'm going to report what this thing's showing. And you can see most of the second order harmonic distortion is here in this lower range, but then when you get into this range here, it's more third order, and you can see that on the spectrum thing on the bottom left. Okay, so that's our testing with the 27 tubes, and next I'm going to pop the 56 tubes in. And honestly, I really like the way these 56 tubes sound. They give a lot higher input sensitivity to the amp. I can run it at about half volume with my system and speakers and my preamp, and while it's not going to be something you would play heavy metal on, some trumpet, saxophone with a little piano and stuff mixed in, it's got a really, really sweet sound to it. So I'll let this thing warm up a minute so we get even test results. And while I'm letting this thing warm up, I did have another really weird problem with this amp that's related to trying to use these almost 100-year-old tubes. I had the amp on its side doing voltage testing, and then just out of the blue, the voltage dropped about 60 volts. And I thought maybe there was a problem with the rectifier tube, or I was kind of scratching my head. And it turns out one of the 47 tubes had semi-shorted out and was drawing a bunch of current, and that's what was pulling the voltage down. And I put another 47 tube in. I've got about 4 of these old Globe 47 tubes, and the voltage came right back where it was. So after I let that tube sit a while, I put it back in the amp and had it vertical, or had the amp sitting on its base with the tubes in the normal orientation. When I first turned the amp on, the current in that tube went way up, and then it came right back down to normal, and the tube started working normal again. So clearly these tubes do not like being run horizontal. They want to be run in a vertical orientation. And I'm guessing what happened is when some of the tube elements got hot, they started sagging and touched each other, and that's where the problem started. So that was kind of a weird thing that had me scratching my head for a minute until I figured out what was going on. So let's see what we've got here with this 56 tube. And you can see now that that green line is a lot lower. The 56 tube does have a little bit more distortion down there in the lower power levels, but in the power levels that you'd be listening to, it's very similar, if not the same. Because right here at this 1.5 watt point, we're still at basically 3% distortion. But instead of being over 2 volts RMS in, we're down to 1.3 volts RMS in to get to that same power level. And so, huge improvement in the input sensitivity. And again, I can tell you from listening to the amp, I can run it just a little over halfway up on the volume knob with my EAR 834 clone phono stage, which again has fairly hot output, and I get a reasonable sound pressure level in my room to listen to. Like I said, this isn't something where you're going to rock out to some Jimi Hendrix or some kind of rock and roll kind of stuff when you might want to crank it. This is not a crank it amp, as you can see, but kind of surprised that 1.5 watts of power with these 89 dB efficient speakers that I have, the Quad S2s, that it seems to do a decent job, and it's definitely a usable amp now with these 56 tubes. And same deal when you get up here to 2 watts, got 6% distortion, but we got 1.7 volts RMS in. So again, very usable. So let's go over here to our frequency response and let's see what we get out of this. And very similar curve, have a little more brightness on the top end, but God, guys, it's like we're talking 0.2 dBs of difference. You're not going to hear that. And if we take this as our 0 dB point, then down here at 40 hertz, we're down about the same 3/4 dB or so, and we're down a little over 2.5 dBs at 20 hertz. So yeah, that still looks really nice, especially when you consider how dinosaur old these tubes are. So again, let's do our scope here. We're hitting the same soft clipping point and at a whole volt less RMS in. So let's come back here and check this thing at around 1 watt and look at some square waves. That'd be about 1 volt, and we'll look at a 1 volt sine wave. That looks perfectly good. But you can see the little bit of distortion, that this is a little narrower than this, and that's the distortion that you're seeing on the THD versus power. So let's look at a square wave at 1 watt. Looks fine to me. There's a little overshoot here on the front. There's no excessive ringing. That definitely looks like a square wave that's going to sound nice. And like I've talked about in the past, when you tune an amp to like round off this ringing on the front end, yeah, it looks good on a scope, but it sounds dead when you listen to it. And most lively sounding amps have this little bit of overshoot right at the very start of a 1K square wave, And so that doesn't bother me at all. So the last thing we want to do is do the frequency versus THD at the same 1 watt and see what the difference is. Okay, we'll pull that up. I'm going to let this run through so you can see the difference between the two. And it actually looks flatter because we're actually at only 4% THD at 20 Hertz, but it's a little higher in this region along in here than with the 27 tube. We got about 0.5% more THD, but honestly, that's not something that you're going to hear. And having a little better frequency response down here or less distortion on the low end kind of makes up for this little bit that it gains right in this area. And let's see if the second versus third order harmonic distortion has changed. Actually, it looks like we have a more even second order harmonic distortion, and with the 56 tube we do have more second order harmonic distortion than third order harmonic distortion, which is a definite improvement. And it's going to make it sound more just warm and tube-like and enjoyable to listen to, more musical, let's say. So there we go on the two different tubes. And again, we picked up a ton of input sensitivity here, and especially in this range here, you're getting 1 volt RMS to 1.5 volts. You're getting 1 to 1.5 watts, and this is probably where the amp's going to get used most of the time, is in this range in here. And like I said, I'm really surprised at how much sound comes out of my speakers with just 1 to 1.5 watts of power. So you can see from the test results, we definitely increased the input sensitivity, and hooking the amp up to my system, now it's totally usable. At like half volume, it puts out enough gain, which surprising to me, with only like 1.5 watts with maybe a little bit of distortion laden headroom, it seems to have enough power to get to a pretty decent volume level. You're not going to rock out with this thing. And, going from half to full volume doesn't make a huge difference in the sound pressure level in the room. But my speakers are only 89 dB efficient. And so, surprisingly, like I said, I think I can enjoy listening to this amp now. It's got a very smooth sound. It's not quite as detailed as like my 300B or my 2A3, but it's got a cool sound to it. And with the right kind of music, especially if you have some piano music that's bordering on fatiguing and maybe has a lot of horns and stuff like that in it, that it sounds really, really, really nice. And I don't put sound samples on YouTube because of all the copyright stuff, but I do have a Facebook page for Skokie Design, and I actually dropped the video with a little 20-second clip of this amp playing some cool music that really fits its style. And yeah, I'm glad that this thing's no longer going to sit on the shelf, and now it can go in my amp rotation. And sometimes it just takes a little while to get motivated to go back and revisit something that wasn't what I hoped it would be. And we've got some other amps like that, I'm sure, that will, maybe 2 years from now, we'll revisit them. But got to get in the right mood. And I was in the right mood to work on this guy. We're kind of in between, waiting on some parts to come in and stuff for some other projects that we got going on. So it's like, yeah, let's knock this out. And again, I want to play with these constant current sources some more. This is a really cool device, and he's actually going to send me one with some different parts or some different MOSFETs that, or FETs or something. I don't know solid state stuff. Anyway, he's sending some different ones that he said might kind of fit the theme of this amp better, but we'll talk about that in a future video. So stay tuned for that. I did show you how the load line is, but we'll dive all into the constant current source in a future video. So anyway, if you're enjoying this content, please like the video, please subscribe. We're getting close to 20K subs. Thanks to you folks that join my Patreon or my channel with the membership. Really appreciate all you guys. And until the next video, have a nice day.